All right, good morning, everyone. We'll get started here. I am Robert Haynes at the National Weather Service, and I have Rodney Chai with me as well. What we're going to do this morning is we're going to just take a moment to look back at the late season winter storm that we had on April 3rd through the 4th. And we're just going to run through some of the details about the forecast, how we communicated the forecast, and a little bit about just how the process was guided as we observed this late season snow event. So we'll talk, of course, about what happened and how much snow fell, look at the primary causes for the event, how was the forecast made and how did models do, and then we'll look at some of the interesting aspects of this storm, and then the overall impacts and messaging with a couple pictures, and then hopefully we'll be able to have a chance for some interactive question and answer sessions. So here's some of the big numbers with this storm. It's one of the largest, or at least it broke a daily record for that day, with Burlington receiving 10 inches of snow in 24 hours. And so at this point, I would say, yes, it is probably our latest measurable snow for this point of the season. We're not gonna, I don't see any chances for snow out there for the next 7 to 10 days. So I think we can safely say this winter season is a wrap. The snow came just a few days ahead of the Great American, North American solar eclipse. And so with our forecast area in the path of totality and the expected travel in the region, there was concern for people coming into the state and navigating the travel with the storm wrapping up on Friday. While the storm overall was well forecast, the snowfalls amount came in on the higher end of the expected range for urban areas, especially within the Champlain Valley. But overall, the forecast was all right. So let's look at some of the forecast considerations with this. So we're going to talk about some of the things that we as meteorologists look at for favorable weather patterns for snowfall events. And one of the things that we like to see when we're looking at a favorable weather pattern is how much air is being ventilated within a storm. And this goes for anything large scale or anything small scale. We like to see a lot of upper level divergence. So when we see these areas of west winds or east to southeast winds across portions of Ontario province, and just off to the east you have west or southwest winds, you can just kind of see how air is diverging away from the region. So that's very favorable for producing precipitation, as well as reducing surface pressures on ground level. And so we saw this large upper low to our southwest, as well as you can just kind of barely make it out at the very top right edge as well, but there is another upper level trough that's sitting over here as well, that's reinforcing these west winds off to our east. So just overall a very favorable upper level pattern for us to be able to receive a lot of precipitation. You see the same thing reflected just a little bit lower to the ground. And if you look again, you can see that favorable pattern for upper level ventilation, just as a result of the east winds across Ontario province, and then the west winds across Maine at the upper levels. So other things that are important is this upper level trough that is also swinging through here. Kind of take a close look at these contours right here, how tightly packed they are. This is just showing a temperature gradient here. So on the backside of this trough, you have cold air being driven in on the backside of this trough. And so normally when you get this, say the southwest wind across portions of the US East Coast, you have a lot of warm air trying to make its way up to the region. However, as a result of this, just this area of divergence here as well, warm air is effectively not making it ultimately very far into Vermont and northern New York right here. So as a result, just the way this trough configuration worked as well, with this upper trough swinging through the Canadian Maritimes, was also an important part of how we maintained as much cold air as we did despite the fact that we were in the middle of the month of April. And so now coming down a little bit closer, so this is 850 millibars. So this would be right about the summit levels. This is about 5,000 feet up off of the ground. The key thing that we look here in the lower levels is we're starting to try and look for moisture in this region. And so any time where you have a connection with, say, the Gulf of Mexico, the Caribbean, or even in this case, you had moisture making a long detour from the equatorial Pacific up through Florida, traveling up through the Atlantic, and then starting to wrap into this large, you have a large area of mid-level low pressure here that's bringing in this moisture off of the southeast to east winds. So that is one thing that we kind of look for. This system had tropical moisture being embedded into the system. As far as how much water was with it, it wasn't anything off the charts, but still, anytime you're bringing this rich tropical moisture in, you're typically going to have a little bit more precipitation than your average system that may draw moisture off of the Great Lakes or any other source. Also, I want to highlight again just how tightly packed these temperatures are. These are the dashed lines here. So anywhere where we're seeing this, where they're tightly packed together, indicates where you have great temperature changes in a short distance. So you can say, all right, I see the area of warm air here and the cold air. So you can be pretty sure that your warm front is located just to our south. And so with that, you can see we have a fetch of cooler air that's being maintained on the north side of the warm front, whereas here at the south of our forecast area, you can see ultimately a lot of that warm air is being diverted off to the west, and then the rest of it will be heading off to the east of where that warm front is located, right around just offshore on the Atlantic. So again, just the way that things were configured, we wound up not getting very much warm air to move up into our area, despite the time of the year. So another favorable forecast consideration to how we got so much snow as we did. And so now looking close to the ground here, we have the surface low pressure. We often like to use the 4070 benchmark, which is right here. So that's 40 north, 70 west latitude or longitude. And if low pressure tracks to the north of that point, like as happened in this event, that is usually favorable for snowfall in our region. If it tracks too far south, then usually areas like coastal New England are going to be the most prime spot for snow. So the low track at the surface was also favorable for us to receive the snowfall that we received. And we've talked a little bit about how much cold air there was. The temperatures along the warm front, they weren't anything extreme, but it was enough to aid in the stronger forcing, and it was enough to prevent the precipitation type from changing ultimately very much. It was nothing off the charts, but it was just enough to get us exactly what we needed. And so now let's look at some of the things that were not as favorable for snowfall. The biggest one is probably the marginal temperatures at the ground level. I've got a loop here of the different precipitation types shown on the high resolution ensemble forecast system, or HREF. And you can see that it has the different precipitation types marked with all the different colors. And there's this blue contour that shows where the temperatures are below freezing. And so typically this is nice, a very high skill, a high resolution, skillful blend of this model guidance. And by doing those blends, you can typically reduce your forecast error. So in this case, you can see that despite the warm temperatures, here at the end of the cycle, it's mostly below freezing, but especially at the start of the event, you can see it's forecasting several areas of snow despite it being above freezing. And then so it's using those high resolution models that are part of the collection that it forms the HREF to determine what the dominant precipitation type is. So areas where you see like more sleet is where the model is, the collection of models that make up the HREF is predominantly showing sleet in these instances. So one of the key things that we saw was just how expansive the sleet was. You can just see it expand across much of the Adirondacks, covering the spine of the greens like well past midnight here. As well, you can also notice there are occasionally these little pockets of clearing that you can observe within this model. We'll kind of let it loop here so we can highlight here where there's relatively nothing happening as precipitation is moving into the forecast area for this event. There's one more area you can kind of see, like the Northeast Kingdom starts to lose its snow as well there. This is models trying to show the effects of terrain shadowing. Remember at 850 millibars, we were kind of pointing out all this east flow off the area. And so as it hits the White Mountain Range, the Green Mountain Range, and the Adirondacks, you're gonna have a little bit of downsloping that takes place. And so all of these different models are gonna show to varying degrees how strong that terrain shadowing is. And so if you see the model showing areas of clearing like you can now see in the Northeast Kingdom, that's showing that the majority of members that make up the HREF are indicating that that terrain shadowing is going to almost completely remove any precipitation from occurring on the forecast. And so we can use these really skillful ensembles to help us determine how strong terrain shadowing can be. And so from this, we were largely expecting there to be very strong terrain shadowing during this event. In addition to the predominant precipitation type being sleet for a considerable amount of time, running from Wednesday evening into Thursday just past midnight. And so, for example, this makes a big world of difference in terms of accumulating snow. So for instance, if you have, say, a 1-to-10 ratio for snow, 1 inch of liquid means 10 inches of snow. But with sleet, it's more like a 1-to-2 ratio most occasions. So 1 inch of liquid would only correspond to 2 inches of snow. So determining your precipitation type can make a large difference, especially when we're dealing with as much liquid content for this event as we were dealing with. So with that, the precipitation type is an important part of the forecast to nail here. And so we think about what's happening upstairs. We think about how the profile of the atmosphere looks and whether or not there's any possibility of being below freezing. But we also want to try and look for dry air. One of the other important pieces of this puzzle is something that's called the dendritic growth zone. Water up in the atmosphere does not precisely freeze at 32 Fahrenheit. It typically occurs more in the range of roughly -10 Celsius to -20 Celsius. That would correspond roughly to the single digits above and below zero. And so we use the software that helps to kind of highlight that region. You can see it getting a little bit lower over time. And we look for moments where there's moisture in it and where it really is lacking a lot of moisture, like at that specific hour. So we look at that for dry air entrainment. We look at things like that just to determine the quality of the snow that we're getting. So if it's saturated, you're going to usually get better quality snow. If it's unsaturated, you're going to get those tiny, dense flakes, or in worst case scenarios, you might get something like freezing drizzle. And so this is a forecast sounding just to kind of show the temperature and the moisture in the event over time. And you can see how the process changes throughout the event. You can see that initially there was air that was relatively close to freezing at the onset. This is the freezing line about right here. And so at the start of the event, it was fairly close. But ultimately, as that upper trough was swinging through, you can see the upper levels of the atmosphere cool. But you can also see just right at the edge of the freezing line, you can see the instances where the surface temperatures were warming just above freezing. And that's something that will not help in your accumulating snow. Another important factor to consider and what's happening up at the higher levels of the atmosphere is what your wind is doing. Oftentimes when you have these strong mid-level winds that sits below your area where you're looking at your snow growth, sometimes you can get the fragmentation of your dendrites as a result of these very strong winds. So as we were observing these forecasts that the mid-level winds would approach 70 knots at times, we were expecting some level of shredding to take place, especially early on in the event. As the event, as you got kind of later in the day on Thursday, those winds really drop off. But then you have the contending factor of the warming surface temperatures. So a lot of small pieces at play, just as far as how this event was going to shape up. And this is just the forecast sounding from Montpelier. This was relatively simple compared to what we were observing the forecast soundings to be at Rutland, Vermont. And so part of the reason why we forecast as little snow as we did at Rutland were for forecast soundings that looked like this, where unlike Montpelier, so again, here's the freezing line. You can see much of this event spent some time above the freezing level, or above freezing between about 700 and 800 millibars. As well, you also had a lot more dry air working its way in the middle levels of the atmosphere that would affect your snow growth. And of course, you also have warm surface conditions as well. So as a result of the abundance of dry air, the above freezing layer, and the warm surface temperatures, overall, it was looking like Rutland would really lose out on the snow totals. And so part of why we forecast as little as we did across areas like Rutland and Addison County were the expectation of features like this. Additionally, you also had, leading up to the event, very strong winds, up to even 75, almost 80 knots at times. And as we look at this layer, again, remember about 800 to 850 millibars is about where your mountain peaks are at. And so we were expecting as well strong downslope winds to be taking place across Rutland and even parts of Addison County as well. And you can see the model trying to hint at the stronger wind gusts if you can just make out the occasional 50s and 60s that are showing up there as marking the wind speeds that it would mix to. So overall, when we were looking at forecast soundings like Rutland, we were quite concerned that they were mostly just going to be a sleet event, as well as just some periods of rain or losing its dendritic growth. So now let's look a little bit about some of these different sites. Let's look at Albany and just the range of probabilistic data and uncertainty pieces that we can see in this. So I've got, this is what was actually observed on the day of. And so Albany being further to our south, they were going to be further entrenched in that warm layer of above freezing air, right around 700 to 800 millibars. And the big thing to me that stood out as I was reviewing this was how much smaller that layer was compared to the forecast. In general, you can see I've just highlighted a very small portion there. But if you were to look at these range of forecasts here at the freezing point, significantly larger in terms of where that layer of above freezing air was most likely to stretch out. I may have marked that a little bit too high. So as far as the depth of the warm layer, models were generally forecasting much more warm air in the mid-levels compared to what was actually observed. And you can just make it out maybe in this shadowy gray color as the observed sounding. And you can see throughout the lowest levels of the atmosphere, colder than almost any of the guidance was hinting at or suggesting here at the national, or I should say there at the National Weather Service in Albany. So those are some indicators that we were probably heading towards a snowier event than a more sleet case scenario. And I'm going to highlight this uncertainty even further with the Burlington ensembles here that we see. I pulled this series of high resolution ensembles for the Burlington area, and you can see just right around 850 to 925 millibars in this range. very wide range of temperatures between below freezing and above freezing in the area. So several models had a warm layer, several models did not have a warm layer. So as far as what we were dealing with, we had a considerable amount of uncertainty with what was happening upstairs. And ultimately, it became clear that the coldest guidance is what won out. I've got one last thing on forecast soundings, because again, I can't emphasize how important this was to why we got as much snow as we did. This is an ACAR sounding. These are taken, so every time, well, not every time, but certain airplanes are equipped with equipment that can take profiles of the atmosphere, sort of like our weather balloons or some of the forecast models in their analysis. But whenever a plane is flying through, that can give really important data on the observation. Moments where you see like this purple, that's a model forecast, whereas this black line is what is observed. And you can already see there's a little bit of a disconnect between the purple and the black line here at Albany. Unfortunately, it looks like this profiler that went through did not have a way to measure dew point. So you kind of get this area where the model is still showing all this high dew point air. And so you can almost assume here then that the model forecast, as far as the try and kind of highlight what it might look like, the model is probably forecasting conditions that were more like this compared to the something like that compared to the black line. Again, just highlighting that overall, it looks like that our weather models overall were much too warm as far as this event was concerned. So that kind of explains why looking at features like that 500 millibar trough that was swinging through far eastern Quebec province was a real big deal as far as maintaining cooler air aloft in our forecast area. We've kind of alluded to the idea of the downslope winds. And so here's just an animation of the winds that were near summit levels. And so ultimately, this is a loop going from Wednesday evening before the wind event occurred. The peak of the wind event was expected to take place overnight and maximize in the southern greens there with those purple colors, as well as the whites in New Hampshire. And you can see it doesn't quite reach as far into northern Vermont and northern New York, and then ultimately starts to peel off to the east. That shift of those fast winds to the east is important. At the end of the cycle, you can see how at some point the winds die down across Vermont and northern New York. And so as a result of that, as we get back to that point in the loop, you can think of like the flow of traffic on an interstate where fast cars move into an area of slow cars, you're going to have a little bit of a bottleneck. And so at the very end of the loop, you could see how you kept those strong east winds, but really across our area, the winds at summit levels almost completely died off. That bottleneck of air at the low levels is really important to maintaining snowfall, especially later into the event on Thursday. So this is some of the things we were observing in different forecast models. And what was interesting is that we've highlighted some of the pieces of uncertainty, but in a lot of ways, despite these pieces of uncertainty, there was still relatively good agreement on plenty of snow taking place. Sometimes we categorize models by how they treat their weather pattern, and we kind of subdivide them in clusters and look at the differences therein. And so in this situation, I have a forecast from 5 days beforehand. And despite all of their differences, so each panel here is like a different cluster. So there's cluster 1, cluster 2, cluster 3, cluster 4, and then just everything mashed together in this middle bottom panel. And despite all their differences, all the variety of their forecast parameters and how they're treating the environment leading up to the storm, ultimately forecasting roughly the same snowfall amounts despite all of their differences. This is a huge confidence boost. So despite seeing a lot of these features in the mid-levels and the concerning low-level temperatures, there was still something to this that was signaling like, all right, you're almost assured to be at least getting something across your forecast area. And then we used kind of the high resolution data to try and fine tune and tweak those points. And so as we get closer, we turn to those high resolution guidance to help us determine the questions of the rates in the afternoon, how that will be affected by the temperatures. And one of the things we sometimes like to look at when we're dealing with these marginal temperature cases, as we were doing, we like to look at the positive snow depth. And so heading closer to the event, we were actually our initial confidence that was very high, that was 5 days before the event. 2 days before the event became a little shakier as we were becoming more concerned about the temperature profile, about the pieces of terrain shadowing here, as well as the greater forecast for sleet. Typically, we trust those high resolution models. They have more layers to the quote Earth's onion compared to a low resolution model like the GFS. So usually they're able to capture warm noses more effectively, the effects of downsloping and the marginal surface temperatures. So as we see features like this, that does raise some concerns that reined in that initial confidence, as well as features even just off of the GFS showing the change in snow depth, which gives a more accurate indication of how your snowfall stacks up against the rate of melting and things like that. So things like even the global model, as you get closer to the event, showing the Adirondack shadowed, showing the Champlain Valley shadowed, and the Northeast Kingdom as well, and the high surface temperatures. Seeing things like this, where the snowfall was more, the positive snow depth change was more in the realm of 1 to 6 inches, had us concerned that despite some of the potential for heavy snow, that even it would not really accumulate quite as much, with even some of the signals in the along the spine of the Greens and the Adirondacks being a little more suspect as well. So some of these features did rein in our initial piece of confidence, and is again part of why ultimately, as we considered the favorable pattern and considered what we were looking at, thinking that there would be little accumulation, especially in areas like Rutland, a little bit less in the Burlington area, as well as some struggles in the areas west of the Adirondacks and in the parts of the Northeast Kingdom. So we had a lot of initial confidence, got a little bit shakier towards the end, but there were still some signals that most of the region would receive at least a good deal of snow. So we issued our warnings and our watches based on ultimately where we had the most confidence. So our initial warnings really highlighted, of course, the Adirondacks, as well as much of eastern Vermont, whereas everywhere else we kind of trended towards advisories, just based off of the positive snow depth change and the other considerations with sleet and downsloping that hinted at there not being quite as much snow in some of the lower valleys. So that runs into that's the look at our model forecasts, the environment that we were set up in, as well as some of the reasons why we kind of forecasted on the lower side of things. I'm going to switch it over now here to Rodney. Rodney will take over and look at our specific forecasts and the messaging that we did for this event. So now I will turn it over here to Rodney.
Well, thank you very much to Robert for giving such a great overview of the environment and some of the considerations that led to this challenging late season winter forecast. So of course, given that it was early April, it was not an April Fool's forecast that we were forecasting, up to two feet of snow across parts of the area. But you also notice that, the official forecast, which is our best, most confident forecast, ultimately had to come up with a number, and we did come up with like generally 3 to 7 inches across the Champlain Valley and also across the St. Lawrence Valley, with higher amounts the higher up you go, so kind of an elevation dependent forecast, which from a climatology perspective, it makes sense because, you know, when you get this far into the spring season, the odds of having, you know, a blockbuster snowstorm decreases pretty significantly, despite the, you know, all the factors that might be lining up for a huge snowstorm. So you can see, I'm just going to toggle through here. So on the left-hand side, that's our official forecast. But, you know, as the National Weather Service emphasizes probabilistic forecasting, and, you know, an analogy that I'd like to use is, you know, forecasting is inherently uncertain. As forecasters, as meteorologists, we try to convey, we try to give a little more certainty to an inherently uncertain, you know, entity, in this case, the atmosphere. And so when we run the models, the model output will give us a range of solutions. And for those of you who are more familiar with statistics, you know, you might have heard us use the 10th percentile, the 50th, the 90th percentile, and very briefly, the 50th percentile is like it's kind of like your median or your mean. So you know, I'll give you an example. So Burlington, for the models are showing, you know, the low end snowfall is 2 inches. At the high end is 13 inches. So the reasonable worst case scenario could get over a foot of snow, although that is kind of unlikely based on what we have seen at the time of the year. So in this case, the 3.2 inches you see is kind of towards the lower end of the range, and the 50th percentile is actually closer to 7 inches. And as the you know, as we got closer to the event, we did raise the official snowfall forecast. So you can see here, Burlington up to 4 inches, and the model guidance is also trending upward as well. So the 50th percentile you can see on the right-hand side is closer to 9 inches, and you can see, you know, the subsequent forecast issuance is more or less the same. So how much snow fell in the end? You can see, so I'm just going to use the pencil tool here. So here is Burlington, right here. You can still see kind of like a wide variety of measurements, and really towards Addison County, it's a lot less. So generally, we did well for the St. Lawrence Valley. You can see Messina 5.8 inches. So they were kind of like the outsiders for this event. And also further down the Champlain Valley, it's because of terrain influence, they got less snow, and they were not in that heavy snow band that, you know, a lot of us saw here in the northern Champlain Valley. And obviously the mountains got crushed with this snowstorm. So, you know, anywhere from 20 to 30 inches of snow. So, okay. And here's the co-op from our observation network, some of the 24-hour snowfall records. Here at the Burlington International Airport, as Robert alluded to, it was 10 inches of snow. It ended up being our biggest snowstorm of the season. And 10 inches is also the 4th highest amount for the month of April, with records going back to 1893. And you can see some of the you know, reports from our observers. I'm not going to read it out loud. I'm just going to let you see, you know, a lot of like eye-popping amounts that kind of record-setting amounts, or amounts that would rank among the top 4 snowfall for the whole month of April. So a very impressive event. So, and here's a radar loop of you know, kind of what transpired. And of course, this is kind of like, even though it is kind of a after the fact thing, you do notice that it's impossible to account for every single location. So this is kind of like the best guess precipitation type that unfolded, but which is pretty accurate. And you can see there's really not much sleet. The blue is indicating snow, and really it stayed predominantly snow even across the Champlain Valley.
Actually, this radar loop doesn't
show
in it at all. It just lumps snow and sleet together.
Okay. Yeah. So, but but we also do know that it's predominantly snow events. So let's see. Okay. So here's the satellite loop. Robert talked about the the upper venting of the atmosphere. So the benefit of looking at satellite data is we can kind of see what is going on in the upper reaches of the atmosphere. So you can, in this case, this is the brighter colors you see are the drier air, and you can, I'm just gonna try to depict here. So you can see here's the low pressure, upper level low, kind of spinning out across the Ohio River Valley. And you have that kind of rich moisture being streaming, kind of almost like taking the scenic route. So it actually kind of goes over coastal New England and then actually pivots back westward. So in a nutshell, we are not short of, in terms of moisture. And so some of the models, high-res guidance went with lower amounts for the Champlain Valley because they think, well, after the initial band of snow lifted through during the pre-dawn hours of that morning, it would be kind of showery for most of the day. So, but in this case, that you have kind of like a conveyor belt of moisture that made for heavy snows for much of the day on April 4th. So, when you have moisture, when you have cold air, you can get snow, and you can get snow to accumulate despite the temperatures being above freezing and despite it being the fact that we are in early April. So, and the other thing that Robert alluded to earlier was the important role of the wind direction. And here, what you're seeing here is the what we call the low-level helicity, and this is something that you might actually see more often in the warm season during the severe weather season. But in this case, this is also very useful for finding out where that heavy snowfall band is going to be. So in this case, you can see on the schematic on the top center corner of this. This is what we call the pivoting band. So in this case, some of the models were suggesting that this band of snow that ended up, kind of leading to challenging early morning commute that morning across the Champlain Valley would occur further to the north, like up into Montreal, into southern Quebec. But in this case, the band was actually set up right over us in the Champlain Valley. And a lot of it has to do with the pivoting band and the fact that this snowfall band was actually able to curve a little bit further south as opposed to being further north. So in this case, the band ended up setting, I would say, maybe 30 to 50 miles to the south of what some of the models were suggesting. So it's that's why Burlington kind of overperformed in the snowfall department. Let's see. And of course, there was also we also have high wind warnings and wind advisories for the region. And what happened was that I'm just going to remove the the drawings I made earlier. So we kind of dodged a bullet here in southern Vermont. We were thinking, you know, maybe places like Rodney could see upwards of 70 mile per hour wind, but it ended up being the strongest downslope winds stayed in Massachusetts. So that's kind of like a silver lining there. So we overperformed in the snow department, but in this case, the wind were not quite as bad as feared. Okay. And here's a sampling of the observed wind gusts. You can see again the strongest winds are really kind of towards the Massachusetts Vermont border. So in terms of messaging, you know, I alluded to earlier how the National Weather Service as an agency, we are emphasizing probabilistic messaging, and every forecast is, you know, inherently uncertain. So like I mentioned earlier, there was quite a spread in for Burlington. You can see here, this is Burlington, and this is what we call the box and whisker plot. And so I did include a schematic here that kind of explains how we understand this box and whisker plot. So you know, as a rule of thumb, the longer the bar you see in the blue bar, the more uncertain the forecast is, because, you know, you could also get 4 inches of snow in Burlington. You could also realistically get almost up to a foot of snow. So the range is really kind of like 4 to 12 inches. And so as forecasters, we kind of have to, if we want to put a number out, you know, we kind of went with, you can see, we actually went with the lower percentile. So it's actually outside of the lower quartile. So it's actually slightly less than the 25th percentile of the potential range of snowfall amounts. And you can see, again, this blue dot for a lot of places is really towards the lower end of what could potentially happen. And you know, in this case, the dynamics of the storm are great, but we are also fighting the strongest sun angle of April, and to the fact that most of the snow is going to fall during the daytime hours. So we kind of hedge our bets, if you would like, and it did, you know, the forecast did play out well for most of the forecast area except for the Champlain Valley. All right, and here in the forecast office, we try to be creative and proactive in our messaging, and so we are very active on social media, on Twitter or X and Facebook. And this was the highway graphic that we actually put out the previous day. So you can see, and we have received positive feedback from the public and actually our emergency management partners, because they like to see how, you know, in this case, it's a very visually appealing graphic that they can visualize how, you know, as the terrain changes, as you go higher in elevation, how the snowfall is going to change. So, and in this case, you did notice that the Burlington, some of our followers highlighted that, oh wow, Burlington is 7 to 13 inches, even though the official forecast was kind of closer to 4 inches. And so the 7 to 13 inches were kind of like, if you go back to the box and whisker plot that I showed earlier, you know, that 7 to 13 is actually closer to the higher end of the forecast, of the range of possibilities. So let's briefly talk about the impacts of this storm. And you can see, you know, for those of you who live in the Champlain Valley, the morning of April 4th, I mean, if you was trying to go to work, it was not pleasant. Just, you know, look at the huge flakes coming down. And the Vermont State Police, one of our partners, they responded to over 110 weather-related vehicle crashes during the strong spring storm. You know, and most of the crashes were occurred during the northern Vermont, in the northern Vermont communities. And so, you know, there were snowfall rates of 1 to locally 3 inches per hour, which was very, very impressive for for early April snowstorm and with marginal temperatures. And of course, we, as Robert alluded to earlier, this was just 96 hours before the Great American Eclipse, and we had a lot of visitors, and turned out 160,000 visitors to Vermont, or 25% of the state population. So, certainly, from a decision support perspective, we were providing decision support services to the state of Vermont in preparation for the eclipse. And you would remember for the eclipse, hopefully all of you on the call got to see the eclipse. The weather was great that day during the eclipse, and we had mostly sunny skies with some high clouds. But from a decision support perspective, the fact that you have up to 25% of the state population coming up to the state, and people who are potentially not familiar with the things like mud season, and people trying to go to the back roads, and we just had like a biggest snowstorm of the season. And so there's a lot of logistical challenges, especially for our state partners. So we were it was kind of like all hands on decks for the whole week, and helping to provide the best possible decision support services to our partners. So it's definitely quite a very the eclipse happening so soon after this late season snowstorm added complexity and unique challenges. And I'm glad to say that I think we as an office did terrific for this stretch, including the snowstorm and the eclipse. And I would just end off with a picture. I remember I took this picture kind of, I was working overnight shifts that week, and I took this picture kind of around midday, and you can see it was 34 degrees in downtown Burlington, but look at how the snow was just coming down, and look at how huge the snowflakes were. And all the mechanism that Robert talked about earlier contributed to those gigantic snowflakes. And doesn't matter if it's the middle of the day, it doesn't matter if it's early April, it doesn't matter if it's 34 degrees. If you snow this hard, you can still accumulate, so even down in the valley. And so this brings us to the end of our presentation, and we appreciate all of you who stayed to the end, and we'll move on to the Q&A session. Yeah.